I welcome you back to this wonderful session on empirical and molecular formula. Now I start attempting the items. I give the solutions to the items which you have well taken note of in the previous session. Now I'm not going to do them in their order. Yeah, you may excuse me, but I'm going to do all of them, but not necessarily in their order. Because if I'm to do them in their order, I am supposed to start with item 13. I'm supposed to start with item 13, but I'm starting with item 14. What does item 14 say? Item 14 says that, hope you have it already in your books. A group of learners were faced with a unique solid substance X, which they suspected to be an element. So they have X which they suspected to be an element. 0.3 grams of the element could burn in air to form 0.5 grams of solid product. .5 grams of the solid product. One of them picked interest in what could be the chemical formula of the oxide of element. However, he did not know how to determine the formula. When they contacted the laboratory technician, he gave them the atomic number. Take note of this, atomic number and mass number of X. So we have atomic number and mass number of X as 12 and 24, respectively. And the symbolic representation of oxygen as this. Now, what does he want? He wants, as a student of chemistry, help the learners to determine the formula of oxide of X. They want us to determine, that is the challenge, to determine the formula of the oxide of X. Formula of the oxide of X. Now the question is, how does X form the oxide of X? Yes, that is important to note. So X forms the oxide of X as follows. 0.3 grams of element X, it is here, 0.3 grams of element X could burn in air to form 0.5 grams of the solid product. So the solid product is the oxide of X. Hope we are together. The solid product is the oxide of X. Now we proceed to our solution. The oxide of X is the solid product, but formed when X combines with oxygen. That is when X burns in air to form the solid product. Therefore, we shall have the following. In this case, we have seen that X with oxygen, they combine to form solid product, and this solid product is the oxide of X. Therefore, it is made up of X and oxygen. It looks like that. Now they want us to find the actual empirical formula. Now this is by guesswork. Yeah, this is by guesswork, but they want us to calculate it systematically. Now the question is, what are we provided with? What are we provided with? The item, let me also take you back to these rules. Where are they? I think they are here. The rules, because I had promised you to dissect them succinctly, to dissect them very well so that you do not complain. Now here are the rules. The first rule says that identify and write down the symbols of elements present in the compound. Now our compound in this case is oxide of X. It is made up of, oxide of X is made up of X and oxygen. Now I have identified the elements present in the compound, X and oxygen. That is rule number 1. Hope you've seen it. X, identify and write down their symbols. I'm going to write them later on, but I've identified them. It is X and oxygen, X and oxygen. Then what does rule number 2 say? Step 2 says that write down the percentage composition or composition by mass of each element. Now, what are my elements? My elements are X and oxygen. 2 says that write down the composition of X and also the composition of oxygen. So the question is, what is the composition of X and what is the composition of oxygen? Now, since you have that item, look at that item carefully. The item gave us 0.3 grams of X. So I have mass of X. I have composition of X, but I do not have that of oxygen. That's why I'm putting a question mark here. And I have 0.5 grams of solid product. So 0.3 grams of X plus the unknown mass of oxygen, they give 0.5 grams of the oxide. Now I can find this unknown by taking 0.3 the other side. Therefore, mass of oxygen will be 0.5 minus 0.3. It will be 0.5 minus 0.3, and in this case, we obtain 0.2 grams. 0.2 grams. So I have now mass of oxygen is 0.2 grams, and mass of X is 0.3 grams. Therefore, I substitute where? I substitute in, before I substitute, the first rule says that now I have composition, I also know the elements. Then the elements present, they are 2 elements present, that is X and the oxygen. Then composition, step 2, write down the composition. Now here I have noted these things down because they were meant to help me determine the composition of each element. The item provided me with the mass of X and the mass of the product, but it did not provide me with the mass of oxygen. So that's why I had a question mark here. So all this information has been helping me to determine mass of oxygen. Now I have mass of X and mass of oxygen. I substitute. What does step 3 say? Step 3 says that work out the number of moles of each element. How do you work them out? Work out the number of moles of each element by dividing the composition by relative atomic mass of the element. So we divide the composition by relative atomic mass of the element. So here we divide 0.3 for X by relative atomic mass of the element. Then I also divide 0.2 by relative atomic mass of oxygen. Now look at that item very well because you have it. Somewhere that item mentions that, the atomic mass, maybe, let me take you back a little bit. 448. It is here. It says that the atomic number and the mass number is the same as atomic mass. Atomic number and mass number of X are 12 and 24 respectively. So atomic mass of X, here we use atomic mass, not atomic number. Yes, we use atomic mass because that is what the step stipulates. It is here. It says that you divide by relative atomic mass, and the atomic mass of X now, 12 is atomic number and atomic mass is 24. For X is 24. The atomic mass and symbolic representation of oxygen is 16 up here and 8. Now, if they give you symbolic representation, the largest of these two, the larger value of these two is the atomic mass. So atomic mass of oxygen is 16. Therefore, substituting back, we shall have the following. Substituting back, we shall have the following. We divide. The step says that we divide. So number of moles of X, we have 0.3 over 24. Then for oxygen, you have 0.2 over relative atomic mass of oxygen. Now, computing 0.3 over 24, we obtain 0.3 over 24, we obtain 0.0125, and also 0.2 over 16, we obtain 0.025. Now we have determined number of moles. What does the second step say? It says that step 4, after determining the number of moles, it says that determine the simplest mole ratio by dividing the calculated moles with the smallest number of moles. So determine the simplest mole ratio is the next step. How do you determine it? Divide the calculated moles with the smallest number of moles. So you look at, these are the calculated moles, you look at them, then you choose the smallest, but here we are lucky they are the same. But if they are not the same, you choose the smallest and you divide by the smallest. So here we shall have the simplest mole ratio. They are the same, so we divide by the same things. So here we obtain, after dividing, we obtain the ratio as 1 to 1. Therefore, in this case, having obtained that ratio, the second step says that if you have the ratio, now what follows is to write down the empirical formula. Now we write down the empirical formula as follows. In this case, we shall say that empirical formula is x. Now x, where we have x, we put a 1. Where we have x, we put a 1. And also where we have O, we put a 1, because those are the ratios that we have obtained. And one does not change anything. So this is the same as saying the empirical formula is XO. And this marks the end of item 14.